For a certain insurance, 10% of policies are type A, 50% type B, and 40% type C. Annual number of claims for an individual type A, type B, and type C policy follow Poisson distribution with respective means 1, 2, and 10. Let X represent the annual number of claims for a randomly selected policy. Calculate the variance of X. So X could be the number of claims for any of the three policies. So if A, B, and C are the annual number of claims for type A, type B, and type C policies respectively, then X could be A, because A is the number of claims from type A, and the probability of that happening is 0.1 because there are 10% policies of type A. Similarly, X could equal B, and the probability of that happening is 0.5 because 50% policies are type B. Or X could be number of claims from policy C. So X could equal C, and probability of that is 0.4. So we know that in this kind of a situation, E of X would be 0.1 times E of A plus 0.5 times E of B plus 0.4 times E of C. And E of A is the mean of the Poisson variable A, and the means of the three Poisson variables are 1, 2, and 10. So E of A is 1, E of B is 2, and E of C is 10. So this gives us E of X to be 5.1. E of X squared, then for this kind of a distribution, would be 0.1 times E of A squared plus 0.5 E of B squared plus 0.4 times E of C squared. And now recall that the variance and mean of a Poisson variable are the same. And the reason why we need to know this is because we need to evaluate these expected values of the squared variables. And for that, we use our basic formula that variance of any variable equals E of A squared minus E of A whole square. And if we do the algebra here, E of A squared is what we are after. So that will be equal to variance of A, and we move this one on the left side, and that becomes a plus. So E of A squared will be variance of A plus E of A whole square. Now we know that variance of A is the same as E of A, Poisson. So for the A, it was 1 and 1. Mean is 1, variance is 1. So 1 plus 1 squared is 2. So similarly, E of B squared will be variance of B plus E of B squared, just following this style. So it'd be variance of B would be 2 because mean of B was 2. So 2 plus 2 squared is 6. And similarly, E of C squared would be variance of C plus E of C whole square equals 110. Therefore, this equation 1, from where we will get E of X squared, now becomes 0.1 times 2 plus 0.5 times 6 plus 0.4 times 110. And that comes out to be 47.2. Variance of X are, we know by our basic formula, E of X squared minus E X whole square. E of X squared is 47.2. EX we found out earlier was 5.1. And that comes out to be 21.19. That is choice C.